Hey everyone. Last week we talked about the law of sines. This week we're going to talk about its counterpart, the law of cosines. In order to work with this, we're going to be working with the same general triangle again. Our same triangle, ABC, where side A is opposite angle A, side B is opposite angle B, and side C is opposite angle C. So we have that. And just like last time, we're going to draw an altitude to make right triangles. And that altitude I'm just going to call H, because H is for height. Now, with the law of sines, we worked with H and C in this triangle because we had the opposite and the hypotenuse. But for the law of cosines, we're not going to be working with the opposite. We're going to be working with that distance. I'm just going to call it x. Since this much is x and this whole distance is b, this much would have to be b minus x. So I hope that makes sense. We have two right triangles, and I'm just going to draw the right triangles separately. We had one where it was A, C, B, H, and X. And then the other one, B, C, A, B minus X, and H. So we have something for each side of the right triangles. And we know an equation that relates all three sides of a right triangle. That equation is the Pythagorean theorem. So we can use that Pythagorean theorem. So, x squared plus h squared equals c squared. And on this one, b minus x squared plus h squared equals a squared. Well, we can expand that binomial. B minus x times b minus x is b squared minus 2bx plus x squared plus h squared equals a squared. So we've got two equations. We've got this equation and we've got this equation. But x and h are not part of our original triangle. Our original triangle, it was just angles A, B, and C and sides A, B, and C. So with these two equations, we want to try and find a way to get it all so it's all in terms of A, B, and C. Well, we have this x squared plus h squared c squared. Hey, there's an x squared plus h squared right there. So we can replace that x squared plus h squared with c squared. So b squared minus 2bx plus c squared equals a squared. And also, well, not also yet. The only thing we're missing is we're missing x. We don't want that x to be there because b, c, and a are all part of our original triangle. But if we look at the triangle where x is not part of this triangle, b minus x is part of this triangle. So we're going to have to look at this triangle. That x is adjacent to angle A, and c is the hypotenuse. So cosine of A equals x over h multiply, x over c. My apologies. So multiply both sides by c. X equals c cosine of A. Hey, so now we have x in terms of things that are from the original triangle. So if we replace that, we're left with b squared, 2bx minus 2b, but x is c cosine of A, c cosine of A plus c squared equals a squared. This is one form of our law of cosines. I'm going to reorganize it so it's a little bit easier to work with. we had this. I'm just going to write it like this. A squared equals, so that term is isolated, I just changed sides. So we have b squared and c squared. A squared equals b squared plus c squared. And then minus 2bc cosine of a. Now this is all based off of our triangle ABC. So that's one version of it. But if we had drawn our height from A to side BC, we would be working with different angles. So this can be reoriented with different sides. If b squared is by itself, so when a squared was by itself, we had b squared and c squared. So when it's b squared by itself, we have a squared plus c squared over here. And was b and c, it's b and c here as well. So when it's a and c, it's a and c here as well. And then the angle is going to be the one that's opposite our side that's by itself. So in this case, cosine of b. And then c squared equals a squared plus b squared minus 2ab cosine of c. So this is our law of cosines. So this is the law of cosines. All right. We'll do a couple examples in some other videos after. But this is where it comes from, and this is what it is. These three equations are our law of cosines. All right, have fun.